Assalamualaikum and good morning. So today we are going to continue with lecture chapter 3, which is the sequences and series. So for the lecture 1 of 3, we are going to focus on the first subtopic, which is the sequences and series. So the learning outcomes for this lecture, at the end of the lesson, students should be able to, the first part of this lecture, we're going to focus on to write the nth term of simple sequences and series. Means that we are going to focus on the general type of sequences and series. And then the second part of this lecture, we are going to focus on the arithmetic sequence and series. So we want to find the nth term of the arithmetic sequence and series, and then to use this sum formula to find the sum the first term of sum of the first term of n term. Okay. What is the definition of sequences and series? A sequence is a function f whose domain is the set of natural numbers. So all of the value is a natural number, the domain of natural number. The value f1, f2, f3 are called the terms of the sequence. So this value inside the function should be a natural number. It's a function, right? A series is the sum of the term of sequence. So we write down the sequence in the form of with comma, but for the series is a sum. So how we write down the series? So we write the sum of the first n term of sequence as Sn. So this is we call as the series. For sequence, it's in the form of comma. So simple example of sequence. So let's say the first one, it can be 1, 3, 5, 7, dot dot dot. So means we have a comma here, so it's a sequence. The other example is 2, 4, 6, 8. So what is this 2 sequence? Can you recognize? Okay. So what is 1, 3, 5, 7 sequence? This is a set of number arranged in an order. So what order is this? 1 plus 3 plus 5 plus 7 plus dot dot dot. This is the series. So it is a sum of the term of the sequence. So we call it, the first part is the sequence with comma, and the second one is the series with the plus sign. Okay, tips. So this one, usually we use it in recognizing the type of sequence. So for example, for 1, 3, 5, 7, this is odd numbers, right? So we can represent it generally as 2n minus 1, where n is 1 for this one. And then for 3, the number of n is 2. For 5, the number of n is 3. For 7, the number of n is 4. Okay, let's substitute in the formula, right? So we have 2 multiplied by 1 is 2, minus 1 is 1. And then 2 multiplied by 2 is 4, minus 1 is 3. And then 2 multiplied by 3 is 6, minus 1 is 5. It can also be represented as 2n plus 1. Why? This is if the number of n starting from 0. Okay, so this is not natural number but whole number because we include 0. So the first n will be 0. So 2 multiplied with 0 is 0, plus 1 will be 1. 2 multiplied by 1 is 2, plus 1 will be 3. So it can be represented as these two general form. Another example is 2n plus 3 if the n starting with negative 1. So it including the integers. Okay, how about the even number 2, 4, 6 and so on? It can be represented as 2n. So this is the only representation of even number. Or you can use 2n plus 2 if the n starting from 0. Another example is 2n plus 4 if the n starting from negative 1. Okay, let's do some example. Find the first 5 terms of the sequence by the following general terms. So if it's the first 5 term of sequence, usually we start n with 1 because n is a natural number. So what we need to do is to find the terms when n is equal to 1. So 5 terms means that n equal to 2, n equal to 3, n equal to 4, and n equal to 5. So let's just substitute all this value of n into the general form of the questions. So for solution 1a, given the n term is tn equal to 2 multiplied with n squared minus 1. So let us substitute the value of n. So n equal to 1, so 2 multiplied by 1 square minus 1 will be 1. And then the second term means that we have to substitute the n equal to 2. So 2 multiplied by 2 squared minus 1. So 4 multiplied by 2, 8 minus 1 is 7. Can we continue to the fifth term? So the third term equal to 17, the fourth term equal to 31, the fifth term equal to 49. So how to write the sequence? Remember the sequence we have the comma. So list down everything, the first 5 term, 1, 7, 17, 31 and 49. So let's Okay, so for question 1b, I want you to try on your own and then I'll just give you the answer. So what is the question? The Tn is equal to n over n plus 1. So the answer is for the first 5 term, 1 over 2, 2 over 3, 3 over 4, 4 over 5 and 5 over 6. So did you get the same answers? If yes, then congratulations. So you can continue. Okay, so example 2. Find the nth term of sequence whose first several terms are given. So what we want to find is the general form, the Tn. Okay, so how can we write the Tn to find the general? So we don't know what is the relation between these numbers, right? So let us do some example. Okay, so for question 2a, so we have 4, 7, 10, 13. So what we can relate from each of this number. So first of all, we can find what is the difference between these two numbers. So let's say 7 and 4, we have a difference of 3. How about 10 and 7? So 10 on 7 also have a difference number of 3. And 13 to 10 also have a difference of 3. So we have a difference between the numbers. We have the same difference of number which is equal to 3. So it can be a multiple of 3. But it's not start with number of 3. We have starting number of 4. So what is the difference between this number 3 and 4? So we have 4 equal to 3 plus 1. So the first term, it may be 3 multiplied with 1 plus 1. So we will have 4 as the result. Let us try the general form with number 2, the natural number 2. So what we will have for natural number 2? 3 multiplied by 2 plus 1 will give us 7, which is, it is the second term of the sequence. So we can use this general form. We have to check for every numbers in the sequence, okay? So let's do for the third term. So what it will be? 3 multiplied with 3 will plus 1 will be 10. And then the fourth term, 3 multiplied by 4 is 12, and then plus 1 is 13. So equal to 13. So every value here is following the number in the sequence. So we can choose this as the general form. So what is Tn? We can write down our Tn as 3n plus 1. So this Tn is 3n plus 1, where n is starting from 1 to 5. Okay, so let's do for question B. Okay, so for question 2b, so we have a sequence of 1 over 2, 3 over 4, 5 over 6, and 7 over 8. So for this one, because it's a general sequence, right, we can separate the numerator parts from the denominator part. So we can just find what is the relation for the numerator and then the denominator separately. So if we see the sequence for the numerator, we notice that the numerators of this fraction are the odd number 1, 3, 5, 7, but the numerator is the a sequence of a even number. Okay, because we have 2, 4, 6, 8. So we can use the general form for the general term for the odd for the numerator and even for the denominator. So what we can write down as the Tn, the nth term. So it should be 2n minus 1, which is the odd number, divide with 2n, which is the even number. And then because we have the dot 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 after the last term here, it means that we will continue to infinity. So that's why it starts from n equal to 1 to n equal to infinity. Okay? Of a sequence or series. So what is the partial sums means? So for the sequence, we know that the partial sums is the addition between the terms. For example, for S1, the first term, so what is the sum? So we only have the first term. That's why S1 equal to T1. How about S2? S2 is the addition between the first term and the second term. Okay? And then the third term continue with first term, add up to second term, add up to third term. So our Sn is addition between the first term up to the nth term. Okay? First term up to n terms. That is for Sn. And then S of n minus 1 is the addition of T1 up to term of n minus 1. So it less one of term compared to Sn. So what about the partial sums of the sequence? We may know the addition from the first term to n terms or first term to n minus 1 terms. The partial sums of sequence can be written in the form of Sn minus Sn minus 1 equal to Tn. So this is the original. To get the n term, we just subtract Sn minus 1 from Sn. So what we can use this formula to find the n terms. If we don't have the formula for n term, we can use the formula of partial sums. So the n term can be found by subtracting the n minus 1 sum of the n up to n minus 1 term from the sum of first n term. Okay, note that T1 plus T2 plus T3 up to T5, we don't have any additional terms, so we call it as finite series. Different from T1 plus T2 plus T3 plus T4 plus T5 plus dot dot dot. So this plus dot 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 is an infinite notation. So this is an infinite series. So some example for sum. Partial sum, given that Sn equal to 2n squared plus 3n. So we want to find A, the sum of the first 5 terms and the next 5 terms. So we know the first 5 terms, we can directly use the Sn formula given. How about the next 5 terms? Okay, so S5, just substitute the value of n, which is we want to find the first 5 terms. So n equal to 5. So 2 multiplied with 5 squared plus 3 to multiply with 5 equal to 65. This is the sum of the next. How about the sum of the next 5 terms? So it should be the 6th term up to the 10th term, not including the first and 2 5th terms. So how to find the T6 plus the T10? So what we can do, we can use the partial sum formula. Why? We know S10 is equal to T1 add up to T10. So we can subtract T1 to T5 to get T6 up to T10. So find S10 first. So what is S10? Substitute the value of n equal to 10 into the formula. So we have 2 multiplied with 10 squared plus 3 multiplied with 10. Subtract with S5, which is 65. So the answer is equal to 165. Okay. So this is for sum of the next 5 terms. For question B, we want to find the 5th term. So to find the terms, but we don't know what is the general formula for the nth term. So what we can use is the partial sum formula. So add a T5 can be found by using the partial formula of S5 minus S5 minus 1, which is S4. So what is S5? 65. What is S4? Substitute 4 into the formula. So 2 multiplied with 4 squared plus 3 multiplied by 4. So the answer is 21. Okay, let's continue with the next part, which is the arithmetic sequence.